Welcome to the Network Plus Prepcast, your dedicated audio companion for mastering every objective on the CompTIA Network Plus certification exam. This series is produced by baremetalcyber.com. IPv6 subnetting plays a central role in organizing the massive address space available under the newer Internet Protocol standard. In this episode, we will explore how IPv6 subnetting differs from its IPv4 counterpart, with a strong focus on prefix assignment, logical structure, and scalability. Because IPv6 offers an exponentially larger address pool, subnetting serves more as a planning and management tool than a method for conserving address. The goal is to maintain a clean, logical, and hierarchical structure that simplifies routing and future expansion, while providing efficient segmentation across various network functions. On the Network Plus certification exam, questions about IPv6 subnetting are less focused on mathematical host calculations and more about understanding how prefix lengths are used to organize networks. Candidates are expected to recognize common prefix allocations, interpret subnet structures, and apply logical planning strategies. You may be asked to identify the subnet mask associated with a given prefix, determine how many subnets are available from a given allocation, or analyze a diagram that shows how a larger IPv6 block has been subdivided for use in various network segments or customer sites. To understand IPv6 subnetting, you must first understand the structure of an IPv6 address. An IPv6 address is 128 bits long and is typically divided into two main parts, the prefix and the interface ID. The prefix is assigned by the organization or internet service provider and identifies the subnet, while the interface ID uniquely identifies the device on the subnet. The standard format for most IPv6 subnets uses a /64 prefix, which reserves the first 64 bits for the subnet and the remaining 64 bits for host addressing. This balance is designed to support auto-configuration and modern routing. Subnetting in IPv6 focuses on allocating multiple /64 blocks rather than dividing subnets based on host counts. Since each /64 block provides a vast number of possible addresses, over 18 quintillion, there's no need to optimize for host density like in IPv4. Instead, subnetting in IPv6 centers on prefix management. You create multiple subnets by adjusting the prefix length and assigning those subnets to different departments, services, or geographic locations. This model improves clarity, reduces routing complexity, and enables seamless scaling. In IPv6 networking, it is considered best practice to assign a /64 subnet to every local area network segment. This approach ensures compatibility with stateless address auto-configuration, or SLAAC, which relies on the assumption that hosts will receive the lower 64 bits of the address dynamically. Using /64 also aligns with router advertisement behavior, which uses these boundaries to advertise subnet information to hosts. Even for point-to-point links or small segments, assigning a /64 remains the recommended standard for simplicity and consistency. When planning large IPv6 address spaces, administrators and internet service providers often begin with even larger prefix allocations. Enterprises may receive a /48 block, while smaller organizations or residential customers might be assigned a /56. These larger blocks can then be further divided into thousands of /64 subnets. For example, a /48 allows for 65,000 /64 subnets, which is typically more than sufficient for even large organizations. This enables each department, service group, or regional site to have its own unique subnet, facilitating both security and scalability. Calculating subnets in IPv6 involves borrowing bits from the subnet portion of the prefix rather than from the host portion, as is common in IPv4. For example, if you are assigned a /56 and want to create subnets, you would increase the prefix length to /60, /61, or longer, depending on how many subnets you need. The idea is to track how the prefix changes as you increment through the space. You do not need to calculate host counts since each subnet always retains a full 64-bit host portion. This greatly simplifies the math and keeps the focus on address hierarchy. IPv6 address planning is most effective when prefixes are assigned based on logical structures such as department, function, or geography. You might allocate a specific range to the accounting department, another to the research division, and still another to remote offices. It is also standard to reserve portions of your space for future growth. Planning must be documented in a clear, centralized manner to avoid prefix conflicts and to support troubleshooting efforts. Proper address tracking ensures that IPv6 subnetting remains transparent and scalable over time. Several tools are available to help with IPv6 subnetting. Online calculators, spreadsheet templates, and prefix planners allow you to easily map out prefix allocations and document subnet boundaries. These tools reduce the need for manual binary conversion, which is rarely needed with IPv6. Because prefix lengths are the primary focus, your attention should be on where the boundaries lie and how they align with organizational need. The tools you use should allow for visualization and quick comparison between multiple subnets within your allocated block. Understanding how hexadecimal characters relate to subnet boundaries is another essential part of IPv6 subnetting. Each hexadecimal character in an IPv6 address represents 4 binary bits, also called a nibble. Because of this, subnetting often happens on nibble boundaries, such as /48, /52, /56, /60, and so on, where each increment represents 4 additional bits. These hex boundaries make it easier to count and assign prefixes cleanly. For example, moving from a /56 to a /60 increases the number of subnets by 16 and alters just 1 digit in the address. Prefix notation in IPv6 is the primary way subnets are identified and organized. A /64 is the standard for end-user devices and internal LANs. A /56 is often allocated to a small customer site, allowing for multiple subnets within that location. Enterprises may be given a /48 to cover all their internal departments and locations. Understanding the purpose and size of each of these prefix LANs allows you to make intelligent planning decisions, design efficient routing schemes, and interpret address blocks quickly during exam scenarios. For more cyber content and books, please check out cyberauthor.me. Also, there are other podcasts on cybersecurity and more at baremetalcyber.com. When designing IPv6 subnetting strategies, routing considerations play an important role in maintaining clarity and efficiency. Unlike IPv4, where route summarization is often done to conserve space, IPv6 is designed from the ground up to support large-scale prefix aggregation. Routers can summarize multiple subnets by combining them under a common prefix, which significantly reduces the size of routing tables. This summarization also simplifies troubleshooting and improves routing performance, especially across wide-area networks and hierarchical infrastructures where clarity and speed are critical. The interface identifier portion of an IPv6 address remains consistent regardless of how the subnet is planned. This means that when subnetting, only the prefix changes. The interface ID, usually the lower 64 bits of the address, is typically generated automatically through mechanisms like stateless address auto-configuration, or SLAAC. As a result, subnet planning in IPv6 is primarily concerned with assigning correct prefixes. You do not need to worry about managing host addresses directly as long as the prefix allocation is sound and the addressing model supports your device's configuration method. One of the most notable differences in IPv6 compared to IPv4 is the complete absence of broadcast traffic. IPv6 replaces the concept of broadcast with multicast, which is more targeted and efficient. In IPv4, broadcast traffic can create unnecessary noise, especially in large networks, by sending messages to every device in a subnet. IPv6 eliminates this inefficiency, reducing overall traffic and improving performance. Since subnet size does not impact broadcast behavior in IPv6, network designers are free to allocate subnet sizes based on structure and clarity rather than noise reduction. Planning for address assignment in IPv6 must also consider how devices will be configured, either through DHCPv6 or SLAAC. The latter assumes that all networks use a /64 prefix, which provides the 64-bit space needed for automatic generation of interface identifiers. While DHCPv6 allows for more centralized control, it may also support other subnet sizes depending on how it is implemented. Your approach to address planning should align with the chosen configuration method. The Network Plus exam may include questions that compare SLA, AC, and DHCPv6 in subnetting contexts. In large organizational networks, it is helpful to implement a hierarchical approach to prefix assignment. This means assigning larger address blocks, such as a /48, to the core of the network, then dividing that space into smaller blocks, like /52 or /56, for distribution to departments, sites, or functions. This keeps the addressing structure logical and grouped in a way that reflects how the organization operates. It also makes routing policies easier to define and manage, since each subnet has a clear and consistent relationship to the overall address space. Security planning is also enhanced by structured subnet allocation in IPv6. By assigning specific prefix ranges to designated roles or segments, such as administrative systems, guest access points, or critical infrastructure, you can define granular firewall rules and access control lists. For example, a firewall might block all traffic originating from a subnet reserved for unauthenticated devices. This level of segmentation supports zero trust principles and makes it easier to audit network traffic, enforce security policies, and isolate systems as needed during incidents. When subnetting problems occur, they are typically caused by incorrect prefix assignment or conflicts in routing expectations. A common issue is using overlapping prefixes in different parts of the network, which can cause unpredictable routing behavior and reachability failures. Another mistake involves applying the wrong prefix length, leading to misconfigured devices or improper network segmentation. Effective troubleshooting begins with verifying that each subnet has the correct prefix, that routes reflect the correct mask length, and that there are no overlaps or inconsistencies in address planning. The Network Plus certification exam places significant emphasis on your ability to recognize and interpret IPv6 subnet structures. While you won't need to calculate the exact number of usable hosts, you must be able to identify subnet sizes based on their prefix, analyze address plans for correctness, and determine how prefixes are used in routing and access control scenarios. Diagrams may show a /48 divided into multiple /64s, and your task will be to confirm that the segmentation aligns with best practices or to flag any planning errors. Fluency in IPv6 subnetting is built through practice that emphasizes allocation logic rather than mathematical host counting. Start by working with common prefix lengths such as /64, /56, and /48, and practice dividing them into smaller blocks using nibble-based logic. Visualize how hexadecimal digits change as prefix lengths increase, and understand how those changes affect route advertisement and device configuration. By reinforcing these core ideas, you'll develop the intuition and clarity needed to tackle any IPv6 subnetting question that appears on the exam. To summarize, subnetting in IPv6 focuses on defining and managing prefixes rather than calculating individual host addresses. Standard subnet sizes like /64 are used universally for local area networks, while larger blocks such as /48 or /56 are used for assigning space to sites and departments. The key to successful IPv6 subnetting is understanding how to allocate prefixes cleanly and logically, supporting both organizational structure and network efficiency. On the Network Plus exam, this knowledge will enable you to confidently answer questions about IPv6 addressing, routing, and design. Thank you for listening to this episode of the Network Plus Prepcast, your trusted audio guide to the CompTIA Network Plus certification. This episode was produced by baremetalcyber.com. For more cybersecurity podcasts, books, and resources, visit baremetalcyber.com. Thanks for joining us for this episode of the Bare Metal Cybersecurity Plus podcast. For more episodes, tools, and study support, visit us at baremetalcyber.com. And before you take the test, Make sure to check out the practice questions in the book Achieve CompTIA Security Plus SY0-701 Exam Success by Dr. Jason Edwards. They cover every domain and are a powerful way to lock in your knowledge.